Another mastery topic for this upcoming mid-quarter 4 test is to simplify fractional exponents. And by that, I do not mean using your calculator. Some of you misunderstood that on the homework, and I can't give you any credit at all if you use your calculator because that's actually not what I'm testing you on. So what I'd like to make sure you know what these fractional exponents mean. So just a general overview. If you're kind of a variable-y type person, you have like a big base number, like in this case that would be the 125. And if you have a rational exponent, and by rational I mean something written as a fraction, I guess in this case, um, let's say you have um, something, I'm going to call this over something. So I'm using all variables. This number is just a regular power. So for example, 5 to the third could be thought of as 3 over 1. We won't write it that way because we never do, but that's just a regular old power. It means the same thing as what you're used to it meaning. 5 times itself 3 times. If there's some number other than 1 in the denominator, that is actually, I'll do that in blue, the root. So, for example, if I had 5 to the 1/3, that would be 5, only it'd be the third root of 5. So again, 5 to the 1 power, well, we never say that, but we could. 5 to the 1 power is just 5. But this number down here is the root. So let's take a look then at, oh, and then the last thing is a negative up here in the exponent spot doesn't mean that the number is negative. All it means is reciprocal. So let's take a look. Well, for example, if I have 5 to the negative 3, since 5 to the third over here meant 5 times 5 times 5, which is 125, 5 to the negative third wouldn't be 5 times 5 times 5, it would be the reciprocal of 5 times 5 times 5. So you still do 5 to the third, you just take the reciprocal. So those are the meanings of all of those parts of a rational exponent. Now let's do an example. So 125 to the 2/3. So I could look at this number as if it were, because 2/3, another way of saying 2/3 is 2 times 1/3. And the reason I want to look at it that way is because I'd rather maybe look at 125 as being, well, let me first separate this out. I'll do this in a couple steps. 125 to the 1/3 power, and then I'll just square that. Remember that with exponents, you can, when you raise an exponent to an exponent, you just multiply. So these are the same thing, but the reason I would prefer to have it written this way is because now I'm thinking that's the cube root of 125. And the cube root of 125 is 5, because 5 times 5 times 5 is 125. And so now the only thing left to do is square that, and I can do that without a calculator. So that's A. For B here, I have 16 to the 1/2 power. That's the same thing as saying the square root of 16, which is 4, because 4 times 4 is 16. But C was a little different because that's 16 to the negative 1/2 power. Now the only difference is instead of being the square root of 16, it's 1 over the square root of 16. It's a reciprocal, which is 1 over 4. And then finally for part D, I have 1 over 81 to the 1/4 power. So that's the same thing as saying the fourth root of 1 over 81, which is another way of saying the fourth root of 1 divided by the fourth root of 81. Well, the fourth root of 1 is just 1, because 1 times 1 times 1 times 1 is 1. The fourth root of 81 might not be quite as obvious to you, but I do know that 9 times 9 is 81. And I also know that 3 times 3 is 9. What that tells me is that 3 to the fourth is 81. Therefore, the fourth root of 81 is just 3. If you have any more problems with that, that's also a checkpoint from a previous quarter, and so you can find that in the back of your book as well.